Okay, so we're supposed to maximize this function subject to these constraints. So basically what you're going to do is you're going to graph each of these four inequalities, and then the intersection points where these cross are the potential maxes or mins. Okay, so let's start just by graphing each of these. Look, it's like a y equals mx plus b type of thing, or you don't even have to do that. You can graph as if this was an equal sign. Okay, and this one's easiest to graph by intercepts. Like if I plug in 0 in for y, I get x equals 5. I'm just making a sketch. And then if I plug in 0 in for x, 2 times 0 is 0, I get y equals 10. So those are 2 points that are going to be on this line, and since it has the or equal to symbol, I can just draw a straight line between them. Okay, that's the first one. The second one, I can do the same thing. Put in 0 in for y, I get x is 12. So somewhere over here maybe. Plug in 0 in for x, and if I solve that, I get y equals 6. So that's somewhere over here. So those are the two intercepts for this line. So it looks something like that. I have x is greater, here actually, no, we'll do the next step in a second. This one is x equals 3. So you want to find where x equals 3, and it's a straight vertical line to make that graph. Okay. And the reason is because if we're trying to graph this line x equals 3, then these are all the points where x could equal 3. And then y equals 1. This is a horizontal line, so it should look something like this. Okay, and so now I'll go back and I'll use the inequality symbols to graph each one. So this graph, it'd be nice if I had it color-coded, huh? But this graph was this line right here. This is graph number 1. So the greater than symbol, to figure out which side of this line we're going to shade, we're either going to shade over here or we're going to shade over here. And to figure it out, I can just plug in a test point on either side and see if it's true. If I plug in 0, 0, which is on this side of the shaded line, 0 plus 0 is 0, and 0 is not greater than 10. So it's false on this side, so I got to shade this side. So here, I will color code these. Let's do this one this way. The red shaded area is over here. So x plus 2y is less than or equal to 12. That was this line right here. Let's plug in that test point of 0, 0, because that's a nice one. If I plug in 0, 0, and it's true, then I'm going to shade this side of the blue line. So 0 plus 0 is less than or equal to 12. That's true, right? If I plug in 0 in for x and 0 in for y, I get a true statement. So this is true. If I plug in that point, this means I'm going to shade this side of the inequality. So we got some overlap there. X is greater than or equal to 3, so here's x equals 3, here's x equals 4, x equals 5. So use a different color for that one. For the green line, we're supposed to graph where x is greater than or equal to 3, so that's this area over here. And for y is greater than or equal to 1, we need to graph all the y coordinates. I'm running out of colors. Let's try that one. So this is our line. So y equals 2, y equals 3. These are the locations where y is greater than 1, so we want to shade this way. Okay, so it got pretty messy. If you're using Newton, it'll look a lot better. But we're looking for where the blue, the green, the red, and what was the last one I did? Blue, green, red, and orange all intersect. This is blue, green, red, but no orange down here, okay? This is blue, green, red, orange. So the intersection is between these two. So I'll draw a quick sketch to show you. So we had two lines that look something like this. Vertical line here. And we had a horizontal line here. So where all those intersect was right here in this triangle. Well, it's not quite a triangle. Is it? Almost a trapezoid, but not quite. So this was the solution area. That's where all four of those graphs intersected. Okay, so now that we know the solution area, which is where all four of these inequalities are true, now we can find the maximum and the minimum by looking at the intersection. So looking at this point right here, this point right here, this point right here, and this point right here. Those are the four places 4 vertices of that shape that we have. So if you're not sure what those points are, you can find them real quick, because this was the graph of x equals 3, this vertical line, and then this line going down here, I drew that in blue, so that was this one right here. You want to find out where this graph of x plus 2y equals 12, that was this line. You want to find out where that crosses this vertical line. Well, then just plug x equals 3 into this equation. So if you solve that, you get 9/2, so 4.5. So this is one of those vertices. This is at 3 on the x, and we got 4.5 for the y. So we got one of them. We need the other 4. So we need to find out where this line, which was the red graph. Okay, so this line is 2x plus y equals 10 in our original graph, this line right here. That was this one going diagonally, right, because it had a y-intercept of 10, so that had the highest y-intercept. Okay, so if we want to find out where this line crosses here at this vertex, it's crossing at the x equals 3 line. So same thing, plug in 3 in for x and solve for y. So we get 6, subtract 6 from both sides, you get y equals 4. So this vertex, this point is 3 in the x and 4 in the y. And then this point where this crosses, this is y equals 1. And where does that cross with this diagonal line over here? Well, we just plug them into each other, right? The graph of y equals 1, the horizontal line. So we plug in 1 in for y, and then we solve for x. So if you solve that, you're going to get x equals 4.5. So this vertex where these cross is 4.5, 1. And this vertex right here, that's y equals 1. Where does that cross with this graph? Well, we just plug in 1 in for y. So subtract 2 from both sides to get x is 10. So this is 10, this is a y coordinate of 1 all the way across, so 10, 1. Okay, so we have all 4 points. We have this point, this point, this point, this point. So the last part of this problem, we're supposed to maximize p of x and y. So you got to plug each x and y point into that function to find out which one is the biggest one. I'll do a few of these. I'll plug in 3 in for x and 4.5 in for y. It'd be quicker if I type. We're plugging in 3 for x, 4.5 in for y. So that's 15 minus 3 minus plus 5 times 4.5. So that's 34.5. Okay, and then we just want to check that with another point. You want to plug in all 4 points, 3, 4, plug that one in next, and just find out which one is biggest. So that's 20, so 17, 35. I got 33. 20 plus 15 makes 35. 35 minus 3 makes, 32, sorry. Okay, so right now this is the maximum, but then you've just got to check by plugging in all the other ones. So the rest of it's just plugging it in and simplifying. So this one would be 5, 10, I think. And if you plug in 4.5, 1, it's going to be something even smaller, I think. No, it's going to be bigger. 10.5 plus 5. I think that's 15.5. So this is the maximum. So that's the 3, 4.5 is the maximum value. And what is the maximum value? So I think the answer to this question, if it's multiple choice or if you type it in, you type in 34.5, because that is the maximum value out of the 4 vertices we found.